Welcome to the Beginner's Guide to the Beginning. The most widely accepted theory of the origin of the universe is called the Big Bang. Now, in science, a scientific theory is a well-established explanation of some aspect of the natural world based on a body of facts that's been repeatedly confirmed through observation and experiment. So there's actually a lot of evidence that supports the Big Bang. This includes redshift, cosmic background microwave radiation, and the evidence from the Hubble Deep Field Image. Now I'm going to explain each one of these in the next videos. So what is the Big Bang? Well, just prior to the Big Bang, all of the matter and energy in the whole universe was contained in a speck less than the size of an atom. Then there was an expansion, and all of the matter and energy has been expanding out from this one singular point ever since. So in the first billionth of a trillionth of a second after the Big Bang, the universe underwent an incredible expansion. It was exponential, and the universe doubled in size 90 times. This period is called the inflation. Now, the rate of expansion of the universe continued, but it did slow. And the universe continues to expand even today. After about the first 3 minutes after the Big Bang, the light elements hydrogen and helium formed. As you can imagine, if all of the energy in the entire universe was compressed into a speck smaller than an atom, it would be pretty hot. As the universe expanded, the temperature cooled enough for matter to form as protons and neutrons, and they collided together to form hydrogen and helium. But for the first 380,000 years, the universe was just too hot to actually shine. The universe was so hot that those atoms of hydrogen and helium would crash together with enough force to break them up into this dense, opaque plasma of protons and neutrons and electrons that scattered like a white fog. So there was no light, just a white fog. So 380,000 years after the Big Bang, the universe had cooled enough that electrons could combine with protons and neutrons to form neutral atoms, hydrogen and helium. This caused the universe to actually become transparent. And at this point, the light that was emitted is what we now know is that cosmic microwave background radiation. Then, for the next 400 million years, there was darkness because there were no stars to illuminate the universe. It was black. We can imagine what would happen next when we've got these atoms of hydrogen and helium floating around, and when they start to get attracted by gravity, more and more of them clump together, more and more become denser and denser and hotter until the point where we have the first stars ignite, and then we have light. And then of course those first stars then clump together with other stars and form the first galaxies. Fast forward billions of years, we're at where we're at now. The universe is still expanding. Stars and galaxies are still forming. Stars go through their life and they die. But the galaxies we see now are more mature, more established. And that is the beginning of the beginning.